Hello, my name is Pavlos Nicolaou, and I'm a PhD student at the University of Kent, and I'm supervised by Christoph Sardi. I want to present you this paper on tracking daily routines of elderly users through acoustic sensing, an unsupervised learning approach. The problem area we're trying to solve is growing in demand, focusing on developing assistive technologies that can support elderly people living with dementia. For example, when the person living with dementia has difficulties following their regular daily routine, skipping or repeating tasks, this might be a sign that can indicate deterioration of cognitive ability. The current state of the art in assisted living relies on wearable sensing and location tracking devices embedded in existing environment. Usually, the elderly are resistant to wearing any wearable devices, or when they do, they forget to recharge them because of their health condition. Using passive audio recording can work without interrupting their daily life, but with one disadvantage. Because of the nature of the scenario, it is impossible to collect accurate labels for each activity. We're focused on taking advantage of the acoustic environment of the person living with dementia by gathering their audio signal that contains a sequence of activities. We are not aware of each specific activity and try to understand if their activity pattern is typical or not. From previous work on audio, we found that it is popular to use embedding features extracted from the raw audio signal. Furthermore, we're comparing the patterns of a known as a typical activity sequence with a new unknown audio signal of activity sequence. If they are nearby in the hyperdimensional space, means they are similar. Our solution to the problem is to use the VGG's pre-trained model to extract embedding features from the audio signal and then use dynamic time warping to match patterns on the time series. Dynamic time warping can be computationally expensive, and for this reason, we will need to use a smaller number of dimensions. Our pipeline consists of passive stage and active stage. The passive stage is where we are making our dimensionality reduction. The active stage is where the unknown sequences of activities are coming in. We are trying to understand if they are typical or atypical. During the active stage, we extract the embedding features from the audio sequence. We apply dimensionality reduction, smoothing, and then we apply dynamic time warping to the embedding features to understand if the signal is similar to a typical audio sequence or not. Our dimensionality reduction algorithm uses embedding features from Freesound audio tagging 2019 dataset, and using k-means, we are getting the cluster heads from each cluster. Then we applied the kernel density estimator for each cluster head midpoint and find the most significant area between those midpoints. Then we compare those 3 points with the embedding features we extracted from the unknown sample. After the dimensionality reduction, we continue with smoothing and dynamic time warping for understanding if the audio sequence is typical or not. We used Freesound audio tagging dataset and the dataset we created from our data collection to develop and evaluate our algorithm. Freesound audio tagging 2019 dataset consists of label audio. We created a dataset using the labels that interest us, specifically the sounds that happen in a house environment, for example, having breakfast, cleaning dishes, and so on. Then we used those label data to create sequences of activities that were 5 minutes of each activity and 5 different activities. During our data collection, we asked 10 participants to list activities during their morning routines, and then they recorded and labeled when they started and finished each activity for 5 mornings. Then again, using those labeled audio data, we manually created activity sequences, evaluate our algorithm with those. Moving to the results, we saw great performances in both the public dataset and our own collected data, with much better performance than the baseline methodology that they used PCAs. Thank you.